Blade rebuild part 15. This will be a reversing switch for the brushless motor. I have a schematic here of what I'm doing. This is a dual pole, dual throw switch. It's rated at 20 amps at 125 volt AC. Here's the schematics here. Let me just kind of explain what I'm doing here. There's 6 lugs on the back of this. These are isolated. These 3 here are isolated from these 3. If you've never seen one of these, when you throw the toggle switch this way, it connects this lug and this lug, and it also connects this lug and this lug. There's a center position where there's no connections, and then I can go this way, and when it's that way, it will connect this lug and this lug and this lug and this lug. I don't know if you can see this. We've got a helper in here. So anyway, so this is the schematic. All we need to do is reverse 2 leads. The motor is a 3-lead motor, so there'd be an A, B, and C. So if you wanted to, we could just finish this out and just say C. And so you got lead A, B, and C. Again, it doesn't matter which one is which one. The direction is controlled by switching 2 leads. So, you know, if we just call this wire A, wire B, wire C from the electronic speed controller, in and out, these are the connections that go to the motor. Well, C will just stay at C, and then we'll switch A and B. And using this switch here, this shows you how. If you cross connect this lug to this lug, and then cross connect this lug to this lug, and you bring your A and your B in, well, when you flip the switch to one direction or the other direction, it will swap A and B, which will give us a directional control on the motor. So I'm going to start putting this together. We'll probably pause it a couple times, but here's the switch. I'll be using again the 12 gauge wire, and I'll be soldering these joints as opposed to using these connectors. Here I had one. There's no possible way to get those wires in there, so I'll just be soldering these. Alright, I will, see, I already cut 2 leads off. And I'll go ahead and strip those. On this connection here, on this specific connection, sorry, this one here, I have to have 2 wires soldered to this connection here. So that's going to be a little tricky. So I'll start out with these 2 here, and then I'll work on the other ones. And then again, I'll be using the bullet connectors. And to give me just a little bit of extra extension when I'm putting these in the box, which I think I showed in the last video, whatever the distance is here for C on the switch, I'll go ahead and just make another lug to extend everything so they'll all have the same distances. Now, I am using the red and black wires here, but the color is not relevant. What is relevant is this connection here. I could use all black wires or all red wires or rainbow wires. It doesn't really make much of a difference. Okay, so let's go ahead and try to solder the first joint here. Alright, set this guy up here. And I'll start out by tinning my connection. And I have my flux. And if you guys are not familiar with soldering, this is I think this is actually designed for soldering copper pipe, but it works the same, I think. Anyway, that just helps the solder flow. All right, again, I do have a, I'm going to use a soldering gun, not the iron. So I'll just heat this up. It tip's a little bent, but it's pretty clean, so it still works. Alrighty, then I'm going to go ahead and just flux the end of this, or tin the end of this wire before I actually go to solder it on the connector here. And tinning is just the process of putting solder on the tip of your wire here. Now with this large a wire, it's really easy to get a good, a cold solder joint. And when you heat this up, you can feel the heat coming down the wire too. Okay, we'll start out with that, and we'll see if my Harbor Freight my Harbor Freight, I guess, soldering jig here actually helps. These wires are so massive. Okay. That's how we're going to do this. I was thinking maybe that I would try to turn them, but I think going this direction will make going straight down will make the most sense with it coming out of the box. Okay, as we can see, this is giving us little problems here. We have 10 minutes of me. Soldering test, try 15. No, I'm just kidding. I finally got my jig set up. Let's see if we can actually do something here productive. We have a micro center here in St. Louis, and when I was there today, I was there yesterday. I was picking up some wires, and what I noticed is that they had a fan that you could use this fan to evacuate your soldering fumes, which I kind of find that odd. I mean, sure, probably you want to evacuate your soldering fumes, but to have a specialized fan I thought was pretty interesting. All right. I'll just quit moving it. So we'll let that cool. Are you recording? Mm-hmm. All right, got the two wires for the out connection completed as per the diagram here. They're going to get prepared to do the other ones. I probably will heat shrink these or do something, hot glue on them or whatever, just so they're not loose. Anyways, I want to give a shout out to my dad. I was visiting him probably like 6 months ago. I mean, 6 months ago when I was visiting him. No, it was probably like last year. And I told him I was doing a bunch of work out in my garage, and he had a electric heater for me, a 240 volt AC heater, and we're going to pan around and show it to you. It's up here in the garage. I got it pointed down. It's got kind of like a dryer plug on it, and the previous owner had a I guess a welder. So there's 240 out here. So it worked out perfect. I did have to go get a new plug and just kind of wired it in parallel, and I'm sure there's a lot of electricians going out there going, oh, you can't do that. Well, technically it works, but whether it's legal, I don't know. But I don't hook up stuff parallel. But anyway, I wanted to say thank you, Dad. The heater really come in wonderful. It's 70 degrees here, and it's probably 35 degrees outside right now. So anyway, I'm going to set up to my next solder joints, and then we'll come right back. Thank you. Okay, so I'm sitting here studying this for a minute, and with this double solder joint here, trying to make this as clean as possible. I'm just trying to figure out, what would be a really good way to do this. And so I'm looking at these lugs, and I'm going, well, what if I drill these out and make them the inside holes the diameter of this wire, and I can strip it down and then either use some heat shrink on it I don't know if I'll be able to fit the this back on, but maybe I can heat shrink across it and it will be secure. I had to pause the video because we're having a technical difficulty here right now. This is Randy and she's on top of the TV. So she's new to the garage, so she's trying to think that, trying to see how much up she can find. Anyway, we'll get back to the wiring here in just a second. Okay, so as I was saying, I think I'm going to drill these lugs out to match the diameter of this and then go ahead and solder and then re-sleeve them. I'll drill these out as well. And then that way it'll be a kind of a cleaner connection. So I will go ahead and strip back one of these wires, try to get a dimension. I'm sure somebody knows that 14 gauge means something, right? Or 12 gauge means some kind of diameter. Oh, my assistant is hooking that up for me right now, and I will do it the other way. Roughly 0.11. We've got 1/8 inch. I'm going to go with an 1/8 inch, which is 12.1250. That's what I'm going to go with, an 1/8 inch. So I'm going to take the drill and put an 1/8 inch hole through all 4 of these. And then I will take and strip this wire back far enough so I could run it through here, then re-sleeve it, run it through here, while I'll solder it, then I'll re-sleeve it, and then I'll put it through here and I'll solder it again. Okay, it's not going to take too long. Okay, so I put it in a vise here, just so I'm not drilling holes through my finger, and we'll just go ahead and I put too much pressure on that and I can see it's bending the tab. So I'm going to try to kind of give it a little counter. I don't know how well that will work. I don't need a bunch of pressure on here, but there we go. That works. All right, I got this one. Okay, we got 2 more to do. Again, I'm just using this wrench to give some pressure so it doesn't bend over. Okay, and the last one. There we go. Alright, I just want to talk about the vise here real quick. I've had some people come over and try to use it, and they go, huh, it doesn't open up. What's wrong with it? Well, this is English vise. It says it's made in England. It's a record. This is a SQ6. And if you tighten it up, it closes, but then when you loosen it, it does not. Now, half of you guys probably know what this is. But the answer is that once you loosen it up, you can slide it all the way open. And then it tightens up and it grabs. Well, if you want to push it in, just loosen a little bit and it will push it in. So you can kind of set it pretty fast. I don't recall. I think I might have bought this like at Home Depot or Lowe's probably over 10 years ago. But I'm very happy with it. So I just wanted to show you one of the tools there. All right. So see how well this plan works out. I've never done this before, it just seemed like a good plan. So I got to strip this back, about yay much. Just rough it. I know some people would get their micrometer out, but okay, using the 12 gauge here. And I know I'm going to pull some of these conductors out. That's not the intent. But alright, and then we'll go same on this, roughly there. Okay. All right. We'll go ahead and feed this through there. I'm not tinning these yet. I don't know if you can see this when I'm trying to push it through. It's spreading out. Okay. There's one. Now, I highly recommend that you do not do this with hot wires. I'm going to go ahead and try to solder this one into place. Here. All right. And I'll put some shielding on it, then I'll get the other side, then I'll do the black. That. I can see a little hole in the other side. I don't know if I'll be able to get back there, but I think I'm going to be happy with that joint there. Okay, so let me grab my heat shrink tubing. Try to find out what would be the correct diameter here. I don't even really know that I need to try to heat this, but just to cover the joint. I do know that once I get this through, it's going to be a pain getting it through that other lug though. So using magic, I got that wire through there. No, that's not what I did. I actually went and bent this tab over. I soldered it a little bit to try to keep the wires together. And now I'm going to solder it to a lug and then cut it off, if I can. And you can see I've got the heat shrink, and actually from just heating the lug up, it kind of shrank on there a little bit. Right. I'll get the cutters here and just cut that off so there's not a whole lot protruding. Give you a take a look there. Alright, so what I think I'm going to do, because the other one's going to have to cross above, is I'm going to strip a little bit more back, just so I'll have a little more playroom. Alright. Alright, I'm going to solder this one. Alright, I'm sure you guys are done with seeing the soldering. I am too. I'm getting a little bit sick of this. It's a nice job, but this is getting a little bit tedious here. falls down, and then more technical difficulties. Okay, it's a good solder joint. I can still see a little hole in the back. Maybe I should have went with the next size down, but I'm trying to start a fire here. Okay. Okay, heat shrink tubing. Trying to get some of these fine wires not to come back and create a short. Quite a trick. All right. So here's what I did with the other one. I'll show you. I went ahead and just took and pulled this lug back like that. And then on the other one, I did go ahead and I tinned just the tip of the lead so it didn't unwind. We got animal difficulties here in the garage. Maybe we can get the show you what's going on here. Randy really likes up on the heater right now. Anyways, we're gonna let her go off and do what she's doing. All right. Somebody told me once a cat had 9 lives, and I have to test that. Please don't, nobody report me for animal abuse. I really love my cat. She's always into everything. If you look at my videos, I've got a cat tree, and when I put the cat tree in, I just thought it'd be something cool, but actually what it really did was change the dynamic of what the cats are. Now they understand up really well, and they just try to go up all the time. All right, if we could hurry up and be done with this part of the project, I'd be thrilled. You can see now the wires coming through there pretty good. I tinned the lead. I want to bend that up. Yes, I'm using the cutter, but I'm not going hard enough to cut. Okay. So all I got to do now is solder and cut that off, and then put the leads on, and we will have a completed reversing switch. All right. Okay. Really apologize for this video being so long and tedious. I'm trying to make them as short as possible. I've been noticing that my times have been going up, so maybe I'd. You know, if anybody want to just give me some feedback, you know, do you guys like the longer videos or the shorter videos? Do you like to just see the work, or do you like the kind of the instruction? Give me some feedback. Let me know what you guys like. That's a pretty good solder joint there. Okay, just let that cool off a little bit. Go ahead and clean it up. Okay. So, per my diagram, I've got the wiring done. I'm going to go ahead and cut these. Take a break. I'm going to cut these, get an intermediate wire, and then we'll go ahead and crimp these connectors. And then we're going to pause for a minute, but we'll come back. We'll crimp these wires, and then we'll try them on a motor.
Go.
Okay, got the solder joints done. I've got, this will be, giving my diagram, this will be the C wire. And in preparing for putting this in the box, I'm just going to go ahead and wire tie this up. Okay, we'll go here too. I guess I could label these, but I'm not going to. Okay, I don't think I'll show you doing all the connectors. I think I'll just show you doing one. We've got 3 males and 3 females. And the way this is designed, it doesn't really matter. There's really, I mean, I know I have designed an in and an out, but it'll actually work either way. But I'm just going to put 3 male connectors on one and 3 females on the other, and then we'll be good. So let's go ahead and I'll just strip and do one real quick. We'll pause it, and then I'll do the other 6, and then we'll go straight to the motor test.